Today I'm going to be talking about the ESRI Culvert Collector Program, Asset Management for Mobile Devices. Just to start off, just a little bit about myself. My name is Matt Retta. I'm a hydraulic engineer with the ODOT for Ohio. I mainly run the Culvert Management Program, which oversees all the culverts and storm sewers in Ohio that are state-owned. So I put on the culvert inspector training, and I also help out with some hydraulic research related to that. Okay, so you might notice the difference with ESRI Culvert Collector and ODOT Culvert Collector. Basically what this means is we've taken a base app from ESRI that is meant to collect assets, and we've taken it and heavily modified it and configured it for our business requirements and our technical requirements at ODOT. So basically what it is it's an easy-to-use spatial data entry app that allows users to record and update the asset database while in the field utilizing the device GPS. Okay, so mainly what that means is that inspectors can go out in the field, they can take a tablet out with them, and they can record all their information while at the culvert and upload it into the database live. Or if they don't have connection, they can sync it back at the database once they come back to the office. In Ohio, we don't always have the greatest cell connection when we're out in the field. So this is a very valuable tool in order to record all our information accurately and reduce human error. So I'll be going over a little bit of our inventory and inspection process for Ohio. I'll go over what we did when we were developing this, because I know a lot of DOTs may be interested in this in the future. And I'll go over the interface a little bit. Okay, so the first priority of the Culvert Management Program in Ohio is to allocate our funding. And so in Ohio, we have 12 districts, and we allocate about $20 million divided to each district based on need. And so the way we determine this need is based on the general appraisal of the culvert. And so that's the culvert's rating for its condition from 0 to 9. So mainly, we want to track this data over time, and we want to allocate these funds as efficiently as possible in order to prevent what our other priority is safety for the drivers. This is taken in Ohio, and as you all know, that a culvert collapse can be deadly, and we take this stuff very seriously, and we do our very best to make sure that none of these situations happen without as a surprise. We want to reduce as much failures as possible. So the way to do that is by preventative maintenance. The other thing we want to do is keep our workforce safe. And so you can kind of see up there. Oh, wait, one of my pictures is missing. That's all right. In Ohio, mainly, we deal with high water. We deal with confined space. We deal with lots of things, cows maybe. But mainly we want to inform the inspectors when they're going out to a culvert that they may need to bring safety equipment. They may need to take a tripod or air monitor with them in order to keep them safe and in order to make it more efficient. You would hate to go out to culvert and not be prepared. So that's another great use of the collector program. See, that's the one that's not in Ohio. That might be in New Mexico or something, I don't know. But anyway, someone could record that information in the collector database and say, hey, this is what we need to come prepared for next time we come back out there. Because we're only going to these culverts every 5 or 10 years. So another priority is research. And we help out a lot in research. And as some of you know, Jeff Sire, we contribute a lot to different research projects in Ohio. And we have used this to start tracking fields over time. As you know, historical records are very valuable for research, and we want to be able to send the most accurate database information to researchers and universities. So we can extend the lifespan of our culverts in the future. So the final step in this, what's going on here? Okay, sorry. All right, that's my final slide. So a final priority is managing our database from a big data standpoint. Before I was in hydraulics, I was in tech services, and we mainly managed big data for ODOT. And what that means is we took all the assets and figured out ways to organize that information in order to make big decision policies. So in the end goal being optimize asset management in the future. Okay, sorry. All right, so here's an example of the ODOT inventory. Right now we're at the Red Star. We're at the convention center. And this is just to give you an idea of how many culverts we really have in just a short span. This is probably about maybe a mile extent, but a lot of people, if you talk to a non-hydraulic engineer, a lot of people don't really realize how many culverts and storm sewers we really have under our roadways. And this is actually a web app called TIMS that we use to show information to other agencies, and we show it to public. And so I'll talk about this a little bit later, but it's something that anyone can access to see our database and see what we're truly working with. So for a culvert to be in the ODOT inventory, it has to be from 12 to 119 inches in span. As soon as it's 120 or 10 feet in Ohio, it's in our bridge inventory. So the other things, it needs to be under a state maintained route or in the right of way, or it has to be an active culvert. We have retired culverts as well, but we don't do anything with those. They're retired. Okay, so I'm just going to kind of zoom out just to give you an extent of how much data we're really, each one of these dots is a culvert or storm sewer. And this is just the belt loop of Columbus. And then you zoom out more, and then you can see District 6. And as you can see, there's just lots and lots of points that it's getting kind of out of hand. And when you finally get to Ohio, we have an absolute ton of culverts. So we have around 86,194 active culverts in our database. So you can see why this is a struggle to really keep up an inspection cycle. And I know it's not an easy task. So we have over 150 culvert inspectors throughout the 12 districts. And so we have the culverts on an inspection cycle, which I'll talk about in a second here. But mainly we have two databases describing this information. We have an inventory table and our inspection table. And the inventory table is the static database of all this, the static information about a culvert. So this is information, think of when you install culvert, you can get the span, the design span, the length, the material type, the gauge thickness, stuff that doesn't really change. The inspection is stuff that changes over time. And so that's the key thing to providing information for research. We want to have historical records, and we're going to have multiple tables it's a joined, so it's a single to many table relation. So we can now relate that many inspections in the future to research projects, okay? So I'll go a little bit over our inspection process real quick. Basically, it's coming back to the general appraisal I was talking about. General appraisal is dictated by color on these maps, and I'll go over the breakdown right here. So on the left here, you see the general appraisal rating. So we rate from 0 to 9, and there's also nulls. Those are ones that haven't been inspected yet. So you can kind of see the color differentiation. You can see the condition as it goes down to 0, we've failed. I know that's kind of the opposite of 1 to 4 being the good condition. But you can see the maintenance. This is just kind of a general thing. When it gets to under 4, that's when we put on an annual inspection. And an annual inspection means that the culvert's in serious condition. We're considering repairing it or replacing it in the near future, hopefully. But otherwise, it's inspected in 5 or 10 years. And then null is, like I said, it's not inspected yet. We have a lot of culverts, and we realize our database is not perfect, but it's kind of an iterative process. Over time, we're going to keep striving towards a more complete database. And sometimes it's just culverts we haven't found. I'm sure if you've done culvert inspection, it's not exact science. A lot of times you come back and it might be a couple hundred feet, it might be missing. It might not have been logged as we tore it out a couple years ago. So those are things to keep in mind when you're working with a database this size. So this is an example of the rating system breakdown. You can see the dots and you see the different colors on there. You see those red squares? Those indicate the culvert is due for inspection. So with the ESRI Collector app, you can put in multiple layers to aid inspectors in different ways. And so you're seeing a base map of aerial imagery, you're seeing the records, and you're seeing a red square on there as a different layer to aid them to know it's due. That's not how we send people out, but at least it's good to know, hey, we haven't found this culvert in a while. Maybe we consider taking it off our database or looking into our plans, finding maybe when we removed it. So here's the rating system breakdown of how we rate things in Ohio. And this one is a general appraisal of 4, so it's in bad shape. And here's all the different ratings that we have. And we rate things in critical, we consider the critical ratings for the final general appraisal value. So only the key things in yellow are what we consider as the final number. If the pavement's bad, it's not necessarily we're going to tear out the culvert, but it might mean we're going to flag it for maintenance somehow, some way else. So basically what I'm saying is these values affect the structural capacity of the culvert. And so we want to keep an eye on these more often. So this is just, I won't go through every one, but mainly this one was the lowest in material. And you can see the material on the edges there, that was the lowest at 4. All right, so we'll go into a little bit how we developed it and how we made these decisions. Like I said, it's an ESRI app. You can download it on your phone or your Android device now, but it won't be configured to collect data the same way. That's why we have a GIS team to help configure it. And we were kind of the business owner in my office, that we had a technical team, and then we took the app. So mainly our goals were to have high-quality base maps. We're going to make it online or offline. We're going to be able to track the users over time, and we wanted to be able to record accurate locations to pair with the database and the LRS. So what the LRS is the linear-based referencing system in Ohio, and that is our routes. And the key thing being is we want to put a record down, and that'll sync to the routes, showing all its location information automatically. So that means it's going to automatically take in the GPS, the route, the county, the section, the district. And so all the stuff is automatically generated, saving inspectors a lot of time and reducing human error. So here's an example of that. So you can see a couple points here, and they're not exactly on the route, although we encourage people to inspect and leave it an official record on the edge of pavement where the culvert crosses the road. That's for it to sync. So on the overnight sync process is when we determine the route information and assign it its CFN, which is the culvert file number. And that's kind of its social security number. It just always stays the same, and we use that to reference it in plans, and we use that to assign work. So when it's all said and done, you'll see these county route sections displayed over the culverts, and that means that it's synced to the route. So on the left there, that synced to a ramp. On the right, on the top right corner, that's Franklin County, 270, mile marker 17.191. So you can see how much time that probably saves an inspector when they're out there, because we have to inspect so many culverts. Alrighty, so I talked a little bit about the sync process already. And I'll just go over a couple of the interface. This is actually the first time I've actually showed you the Collector app interface. So you can pull up the maps, and you'll see on the left that we have all different types of databases in there. We've started tracking, we started with culverts, we started doing BMPs, we've done guardrail, we've done ADA right-of-way, And we've done a couple other things. And then what you're seeing in that cloud is showing 5, that's sync. So that means that the culvert inspector needs to go back to the office, sync to the database, and now all the data is now officially in there. Okay, so there's also center on position. I'm just going to show you a couple things that help to aid the inspectors. You can bookmark a location. You can put on extra layers to save time, like that frequency of inspection. So we have culverts that need inspected this year, next year, 3 years from now, so people can get ahead if they want. So we've got a measurement tool in there. So you can estimate maybe the length of a culvert. It's not always easy to measure it, depending on how much water there is in there or blockage from you actually accessing the culvert. So all just small tools. And then one of the key things is the base maps, and that provides the imagery so you can find it in the future. So if you're walking to this culvert for the first time, it's great to have a high definition map in order to see your surroundings. So here's our inventory form. I know that's I don't know if that's too small to read, but we have just some of our fields that the inspector can drop down and select. So you can see that we have State Department of Transportation. That means we own it. We have the length. We have the rise. We have the culvert shape. We have the material. These are all things, like I said, these are all things we can add on the first day. So that's what makes it the inventory form. The inspection form is what changes over time because we have multiple forms. So this is the inspection for this culvert. And we have general appraisal of 5. So this culvert's in fair condition. And so you can see we've taken these values, and that final value is showing that this culvert's yellow and good, in decent shape. It's not great, but we might be inspecting this in the next 5 years rather than an annual cycle. Okay, so basically we have a couple supporting programs that we put into this called the web editor. It's basically the app, but it's in a browser. So someone who's reviewing culvert inspectors, they can go in and edit and review stuff for plans, maybe put some of these new inspected culverts right into a construction plan, reference these things, and check out what the users have done. It shows a generated list of what the user has done in the last week or month. So that's pretty helpful. Then we also have a supporting program, TIMS, and if you're interested in implementing Collector at all in the future, I highly recommend going to TIMS and looking at our databases. You can see what fields we have, what we've chosen to collect, and it's open to public, so you can see all of our culverts. And so this snapshot here of these purple culverts, they're basically all our state-maintained culverts, well, in the Columbus area. So if you just search on Google TIMS ODOT, it'll be the first one that comes up. And I might be able to provide a link somewhere for you guys. Or if you come talk to me after, I can show you. Just to wrap up, in conclusion, we've inspected around 15,241 culverts since July of last year. So this program has been very helpful for that, and all the green squares are culverts that were inspected. And mainly it's helped improve our inspection speed and consistency. It's helped track safety conditions. It's eliminated maintenance sources of database error. It's increased reliability of location information, and it's simplified distributing work to inspectors. And so the GIS team estimates that we've saved already $4 million from this program in the last year. Alrighty, so that's all I have. Do you guys have any questions for me?
Yeah, all the culverts and storm sewers were dots. If there's a longer culvert or longer storm sewer, have you considered using lines, or why not use lines?
That's a good question. We brought that up before, but it's kind of like, it comes down to a time and effort thing. I think we could do that, and we have done that for barriers and other things, but we've chosen to stick with the point. We could do that in the future, but it just takes more time.
Software allows it.
Oh yeah, absolutely.
Any other questions?
Do you use this database in any way in response to emergencies? Say you have a big flood and your culvert gets blown out. Is there any workflow in terms of the response to that emergency that involves this database?
Yeah, basically, if something emergency happens to a culvert, we expect our inspectors to just, expect our inspectors to call the bridge engineer right away rather than fill out the form, because we might have to close the road, we might have to do things. So if it's going to be in here, we're going to see a failure, most likely it's on an emergency contract, or we're taking care of it. So the inspector, while this program is part of their job, that's another part that'll flag it quicker. You know what I mean? Now, we are tracking it, so if we start seeing ones getting to a 3 or 2, that we know, oh, well, let's put these on our construction plans while we're at it, so.
I guess you said that the ESRI collector basically was heavily modified by Ohio DOT GIS folks. I don't know if you had, what type of specific expertise that you had to have in-house to be able to do that. And the second question is, were there other products that were considered in terms of, maybe having a better interface or user interface for your folks out in the field?
Good questions. Well, mainly, you have to have at least a GIS person. I'd say that's the first step. I didn't configure it myself, and the team did a great job at ODOT, and we have a team of about 5 people that are configuring this. However, I've seen other states do it with less, and I think their program might not be as robust as ours, but I don't think it's a super complicated thing. They're not programmers, they're GIS people. So if you're an ArcMap enthusiast like I am, you might be able to do it. It just depends how much time you have. Sorry, what was the second question?
I guess if they had considered other types of platforms.
Oh, right, okay. No, I don't think so. Because we're trying to move towards, we're kind of putting a big push towards ArcGIS and GIS stuff at ODOT, and we're kind of working with them in that realm. We're an enterprise. I probably should have mentioned that. ODOT, we have an ODOT enterprise licensing. So that allows us to do this and allows us to get their support. So they'll help us out every step of the way. So that was a big help to them. I didn't communicate with them, but unfortunately my co-presenter is not here today. He's doing a presentation on the same thing in a different state, but he would be able to answer those questions a little bit better.
So one thing I will say on that, I'm from ODOT also, is the IT or the tech services folks at ODOT are, I think, willing to share some of the files they use to translate from vanilla ESRI to our fancier version. So if you're going that direction, you should not start from zero. Call us and kind of look through that file.
Yeah, absolutely. Definitely get my contact information, and I will forward you to the right people, at least the GIS people, and yeah.
Any other questions?
I have a question for you.
Sure.
You mentioned that everything over 10-foot span is a bridge. That's discussed for a bridge.
In Ohio, yes,
Does that
for
go
ODOT.
to the NDI, and does that get inspected every 2 years?
Actually, ODOT, anything 10 foot or over is considered a bridge, and we inspect bridges every year. So
Okay.
we tend to take it a step farther.
Any other questions?
All right. Thank you.